का आवाज नहीं आ रहा इसमें।
The Indian Association of Structural Engineers, also known as ISTRUCT-E, was conceptualized and constituted in the year 2002 by a group of senior professional structural engineers from all over the country. ISTRUCT-E is registered under the Societies Registration Act 21 of 1860. ISTRUCT-E is a national apex body of structural engineers in India with a mission to promote structural engineering profession and cater to the professional needs of the structural fraternity. In the short span of 2 decades, association has attained an eminent position in the professional field. Its membership is valued very highly in the profession. Since inception, ISTRUCT-E has been led by eminent structural engineers like late Shri Mahendra Raj, late Shri Shri Kumar Ghosh, Shri Subhash Chand Mehrotra, Professor Mahesh Tandon, Shri Alok Bhaumik, Shri Manoj Mittal and Professor R. Pradeep Kumar. As its president, ISTRUCT-E is a permanent member of Engineering Council of India and interacts with the government on professional and policy matters related to civil and structural engineers. To expand its reach, ISTRUCT-E has collaboration with various international professional like-minded associations and institutions. ISTRUCT-E's prime objective is supporting and protecting the profession of structural engineering by upholding professional standards and acting as a mouthpiece for structural engineers in India. ISTRUCT-E endeavor to ensure that its members develop the necessary skill in structural engineering and work to the highest standards by maintaining a commitment to professional ethics and standards. ISTRUCT-E is actively engaged in organizing several continuing professional development (CPD) courses for structural engineers to help them update their knowledge and advance their career paths. It also conducts refresher courses for young and practicing engineers and student-oriented programs. Seminars, workshops, conferences, technical lectures and discussions related to the latest technological advancements and case studies are also organized regularly for members to enable them to continuously update their knowledge and skill set by interacting with the best minds from the industry. ISTRUCT-E's activities are widely appreciated and known for quality technical contents. ISTRUCT-E is also actively engaged in publishing its quarterly journal Structural Engineering Digest (SED), code commentaries, professional guidelines, and a monthly newsletter. ISTRUCT-E's publications are becoming popular with time. ISTRUCT-E has representation in various technical committees of BIS and IRC as well. Its members are actively contributing to National Code of Formulations. In the year 2020, ISTRUCT-E started National Awards competition to stimulate interest in the structural engineering field and to promote innovative thinking and creativity. The awards are presented to the winners in recognition of their outstanding contribution to structural engineering in the categories which include Outstanding Structure, Outstanding Structural Engineer, Outstanding Woman Structural Engineer, Promising Young Structural Engineer, and Best Master's Thesis in Structural Engineering. ISTRUCT-E is currently operating from 4 regional centers, namely Eastern, Western, Northern, and Southern, having its headquarters in Delhi to inculcate the professional culture and provide handholding to the budding engineers. ISTRUCT-E has its student chapters in several leading engineering institutions as well. Membership of ISTRUCT-E is open to all civil and structural engineers engaged in structural engineering profession. Members are elected based on their qualifications and experience in different grades as per eligibility requirements prescribed in the bylaws. Each application is carefully scrutinized before More information about IA Struct E is available on its website www.iastruct.co.in.
Should we start now?
Yes.
Good morning. Welcome to this very important webinar on confidential reporting of structural failures, which is a newsletter started by IA Struct E some time back. And the aim today is to know what is this newsletter all about, how we publish it, why we publish it, how you can contribute a report in this newsletter, and how it will be useful to the fraternity and other stakeholders. So I believe that today I have very eminent speakers today who are involved directly with the publication of this newsletter Crossfall. And I have Alok Bhaumik, who is the chief editor of the newsletter, this newsletter, who initiated this newsletter actually. And he is a very well-known bridge structural engineer, and he's also past president of IA Struct E. I also have Professor Mahesh Tandon, who is also eminent structural engineer, bridge engineer. Everybody know him. He is also past president of IA Struct E. And then also have VN Hegde, who is also governing council member and vice president west of IA Struct E this time. He is also well-known bridge engineer and also the part of this committee. And I also have Mr. Rajiv Ahuja, who is also an expert structural engineer, well-known bridge engineer, also governing council member of IA Struct E. And he is also involved in the editorial board of this newsletter. So I have all the people who are directly related with the publication of this newsletter. They know how and why this newsletter is being published. So today aim is that we should be able to know why we are publishing this newsletter and what is the purpose, what is the format, and how participants can contribute in the public in this newsletter, and how it is important for them to contribute and to read this newsletter. With this aim, I think I will like to invite first of all Mr. Alok Bhaumik. Alok, all the speakers will have 10 minutes, and I will give them 10 minutes. If they will exceed, then I will just inform them. So Alok, you can start your presentation.
Thank you, Manoj. Am I audible?
Yes.
And is my screen visible?
Yes, visible.
Okay, I think I have to swap a little bit.
You have to go to full screen mode.
Yeah, just one moment. I don't know how to swap that.
You are not able to see that. No. You have to duplicate that. Hello, not.
Okay, just one moment. I mean, I think there is some problem which I'm facing.
Yeah.
Just give me 1 minute. I will try to do that.
Yes. It's okay.
But are you seeing the two slides or single slide?
No, single slide. It's okay now, I think.
Oh, you are seeing single slide. Okay. So, thank you. Good morning and good afternoon and good evening also, because I understand that some of the participants are from different parts of the world. I know some people from Malaysia also has joined. So basically, my presentation will be giving a broad outline of what Crossfall is all about. Somehow I'm not able to move the slide. there is some problem. Just give me some.
Yeah, moving.
It is moving, is it?
Yes.
Yeah, moved. Now you come
Oh.
back.
Okay. Okay. Oh. Okay. Are you able to see the
Why
second
worry
slide?
about safety?
Okay. Okay. Thank you. Thank you. Somehow my screen is probably not in tune. Anyway, so first and foremost, let me just mention that why we have started this magazine or newsletter, quarterly newsletter, which is by the name of Crossfall. We have seen number of failures, in last decade or so in India, particularly. But I think the failures are being witnessed all across the world. Only the frequency may be different. And there is a news of damage also not only on the bridges and building side, but also due to climate change. We have seen in many structures and bridges, particularly because of the change in the high flood levels. We have seen several bridges failing. Now, we need to, sort of learn from these failures, but unfortunately, the system is such that generally after failure, we find that the investigation reports are not made public, and therefore we really do not learn from the past failures. Reasons why they are not made public is debatable. It's another sort of material for debate, but due to some reason or the other, these are not made public, and therefore we thought, in line with a similar journal in other parts of the world, like Cross in UK, we have thought that it is better to start a newsletter where we publish confidential reports, which means that we publish reports where we do not name the agencies, the stakeholders involved. We do not name the project. We only talk about the failure based on the reports which we gather from the structural engineers and the civil engineers. And we then have an expert panel who will go through those reports, and they will give their expert comments in the form of, what lessons we learned from such failure, and what should be the, we give an alert as to what changes are required when somebody is designing in future. Now, these are glimpses of some of the, well talked about failures which we have witnessed in India, where many fatalities were involved. Recent ones in Sultanganj, in Bihar, in July 2023, and a couple of, I think in 2022, we had this Morbi bridge collapse where 141 people died. And all these failures reflect that if we had only taken care in terms of proper detailing, design, inspection, maintenance, probably we could have avoided such failures. Now, let me come back to what is crossfall. Basically, crossfall means every letter in this word has got a meaning. C is for confidential reporting of structural failures and lessons learned. I think the crossfall, in short, means this. It's a quarterly newsletter, and it is produced by Indian Association of Structural Engineers. We all know, I think most of the participants are well aware of the IAS Struct, but still, for those who are participating for the first time, it is a professional learned society in India with the prime objective of supporting and protecting the profession of structural engineering by upholding professional standards and acting as a mouthpiece of structural engineers in India. Why we initiated this crossfall, I mentioned earlier. It was initiated last year. We have completed 1 year. We have already published 4 newsletters, and the 5th one is going to be published very soon, within a week's time. And I mentioned that it is an e-newsletter which is freely downloadable from the IAS Struct website, and it has it is basically not only it gives the failure report, but also the expert comments on the failure. What can be reported? So far, we have been getting the report on failures, but we have made it clear in our website that we can report on planning and design stage issues, we can report on construction stage issues, operation or occupation or service stage problems related to the structural failures or near misses, and even we can report on the end of life structures and safe disposal or demolition of the structure. We would also like to cover issues related to computer modeling issues in some projects, which has led to erroneous design, even if it doesn't mean a failure. But if somebody wants to highlight certain design practice or the analysis practice which is wrongly done in some projects, that can be done, and we can highlight that. We can also highlight seismic safety and fire safety issues and competence issues in design and construction. These are our aims and objectives. But so far, last 4 newsletters, we have published 15 reports, and what we find is that we are not getting reports as we expected, and we would in fact through this webinar appeal to all the participants to seriously consider reporting failures when they experience it in confidential manner, so that their names, the name of the stakeholders, will not be published. Source of inspiration for Crossfall, I mentioned, is Cross from UK. But actually, prior to even Cross UK, the newsletter, there is a NASA confidential close call reporting system, which was initiated for aviation industry, and which was also followed by Cross UK. And when we say Cross, it is basically a joint effort of 3 organizations, very reputed and very old organizations like iStruct UK, which is having more than 30,000 members. Then Institution of Civil Engineers, which is more than 200-year-old and which is perhaps the oldest association in the world. And the HSE, which is the Health, Safety and Environment, in UK. They produce actually 2 documents. I mean, there are 2 agencies here involved. One is COS, which is the Standing Committee on Structural Safety, and the CROSS, which gives the confidential reporting. This COS is basically a committee which gives alert to the government based on the reports which is published in CROSS. And we have taken inspiration from these documents, and we thought that a parallel document we should provide. In short, what is the benefits of confidential reporting? It promotes cultural change in the profession. People become the designers who will may not be, while designing, may not be aware of what are the precautions to be taken when they go through these reports, and they understand a similar bridge or building had this problem and collapsed. Then probably they will take care while designing. And same is in the construction. It provides an opportunity for the engineering fraternity to learn from others' experience. It acts as a tool for bringing changes in the code, standards, and specifications. And it helps to improve the competence level, source of learning for not only the practicing engineers, but also for the students, academicians, and the researchers. No blame is attributed to anyone. Therefore, reporter feels free to share the facts. Truth comes out in such reports. It's a proactive system. It identifies a precursor, and it acts in the interest of public and society, and protects our well-being. The operating system of Crossfall in our internally is that anybody can submit a report. A report is submitted in an email ID which is given. That is only accessed by chief editor, that is myself. And I go through the report, and first thing that is being done is declassify the report, which means even if the reporter by mistake puts somebody's name or some project's name, that is identified and deleted, removed. And this declassified report, which does not contain any name, any organization's name, any individual's name or project's name is now circulated to the editorial board. We have a elite panel of editorial board, and they finally sort of go through the report. If the certain things are missing, that is pointed out, and through the chief editorial board, there is an interaction with the original reporter. And once that report is finalized by the editorial board, it is finalized by the expert panel, then it goes to an expert panel. The expert panel is fixed by the editorial board based on the nature of project which is reported. If it is a building, then we go for experts who are experts in the particular field of building or bridges, etc. And once we receive the expert panel review report, then the finalization of that particular report is made, and we compile it and circulate the newsletter through our website and through our mailing list. This is the process, and so therefore a lot of confidentiality is maintained, while doing this. These are the 4 reports which so far we have published. The first issue started in July to September 2022, which was published in October last year, and then thereafter last issue is June 2023, published in first week of July, and the next issue is going to come in first week of October. These are the various, you see the first 3 newsletter, we had 4 case studies reported, and the last one, which is having 3 case studies reported, the one which is going to come in October will have 3 reports. So altogether, so far we have published 15, and 3 more will come in the next issue. To conclude, I would say that in light of the recent spate of infrastructure failures, professional associations should be active in promoting newsletters like Cross, that is published in UK and many other parts of the world, or Crossfall, which is published in India, and the like, and help to reassure society at large that infrastructure is safe. Success of this newsletter will depend a lot on receiving reports from individuals, firms, and regulatory bodies. All of you can contribute to Crossfall by sending concerns in confidence to crossfall.iestruct@gmail.com. Thank you very much.
Thank you, Alok, for giving the information regarding Crossfall in comprehensive manner. And so I hope now participants understand what is Crossfall and why it is being published and how it is being published. So now I would like to invite Mr. Rajiv Ahuja, who will share a report which was published in one of the newsletter, and I think it is related to the bridge or something. So now I request Rajiv Ahuja ji to make a presentation on that. Now idea is here so that participant can understand what kind of reports are being published in the newsletter.
Thank you, Manoj ji. And good afternoon and good morning to all. Can you see my screen, please?
Yes.
Yeah.
So I am presenting one article from the very first volume, that is July-September issue 1, volume 1. So this is how it looks like. This is regarding failure of a PSC segmental box girder during precessing. See, of late in last couple of years, we have seen several such failures. Whether in segmental construction, when you do the precessing, the segment gets crushed at some location, or either it collapses, and the reasons may be common to all such failures. So this is about a span which is about 60 meters long and done by segmental construction over a river bridge. All the segments are precast, and these are supported on ground supported supports. So it was a simply supported case, 60 meter span over a river bridge with an overall width of 12.5 meter. And the erection of precast concrete segments was carried out by using trestle supported arrangements. As you know, after the segments were joined through epoxy gluing, which is a normal procedure between adjacent segments, the precessing cables are stressed as per the drawing for either from one end or from the both ends. During the stressing of the last 2 cables, cracks developed on one blister of a segment. There was blister blocks for intermediate curtailment of segment, and cracks developed in one of the blister. In addition, hogging and crushing of concrete were observed at the interface of certain segments close to the midspan. So what was done to start with, the superstructure was totally de-stressed. All the cables were taken out from the span and the segments were shifted to the casting yard. And then it was decided to investigate the cause of cracking and crushing by a third party. A third party was engaged, and issues investigated by the third party are review and checking of the design and drawings of the superstructure. We normally always do. Then patterns and causes of cracking in the segments, quality and strength checks, including NDT tests, cause of busting of blister blocks, cause of concrete crushing at the junction of segments during stressing operation. Then feasibility of repair of segments affected by the cracks and checking the adequacy of segments not affected by the cracks, whether we can use these segments again after repair, and the existing segments, whether those are cracks free without any problem. So that was also one of the issue investigated. And the result of investigations are deficiency in design. There were some deficiency in design also. The construction stage analysis was not done for checking stresses due to lifting and stacking of the segment. In this case, normally what is done, one segment is stacked over the lower segment, but it's very important to see whether these do not cause any undue stresses or cracking in the slab or cantilever slab. Supports have to be organized properly. The isolated intermediate soffit blisters are anchored in the middle of the soffit and not at the junction of the web and soffit, which is not a desirable practice. Normally, we provide blister at the junction of web and soffit, but in this case, it was provided right in the middle of the the soffit slab. The reinforcement provided in the blister block is not detailed adequately, and the critical end zone of blister is left unreinforced. Drawing shows the provision of additional reinforcement in the soffit slab as tie-back reinforcement for the tensile load transferred from the blister, which is not feasible to provide such reinforcement in precast segmental construction. Normally, we provide a tensile reinforcement at the bottom of the blister to transfer the tensile forces beyond the blister block. But in this case, in a precast segmental construction, that may not be feasible. But drawing showed such kind of detailing. Then the concrete quality and strength. Concrete cube tests were found to be acceptable as per codal specification. However, NDT tests such as core testing and sheet hammer test established that actual concrete strength was far below the design strength. Now, this is a very, very important point. We are normally satisfied with the cube test results, but the actual concrete core may be quite deficient and may not meet the quality standards. Failure of anchorage cone in the intermediate blister occurred due to inadequate reinforcement and poor compaction of concrete. The anchorage cone at the blister had an edge distance less than the prescribed value as per the manufacturer's catalog. Longitudinal transfers, star-shaped and scatter cracks were observed at several locations in the soffit slab, web, deck slab. The cracks measured by a specialized agency are reported of width varying from 0.1 mm to 0.3 mm and depth varying from 30 mm to 100 mm. Honeycombing was also observed in almost all the segments. And then edges were found damaged in the anchorage cone, cantilever slab, bottom slab, deck slab at several locations, maybe due to inadequate handling of the segments. And crushing was observed, of course, in the concrete. The workmanship, application of epoxy in the joints of the segment was not carried out properly, and the epoxy resin as applied was set even before joining of the segments. The hardened epoxy is likely to prevent 100% contact between the match cast segments, thereby increasing the stresses at location where there's a contact established. Now, this is a very common problem, especially in a very, very wide deck. Today, decks are 25 to 30 meters, even more than that. So it is very important to ensure contact of the adjacent segment 100%. Variation in web thickness is up to -10 mm, that is lesser than required, to 30 mm, that is more than required, which results in mismatching of adjacent segments. Reinforcement was found exposed at a few locations. Shear keys of the segments were also found damaged at some locations. Existing concrete cover in various segments has been carbonated up to 70% of design cover in a very short period of about 2 years, which means the concrete is permeable, and in just 2 years, the carbonation has taken place up to 70% of the design cover. This shows that concrete is porous and honeycombed with high probability of corrosion in steel reinforcement in the near future, which will induce spalling, cracking, etc. Water absorption results reveal that it is in the range of 2.53% to 5.15%, which is beyond the maximum limit of 3% as per IS 516 And the results reveal poor quality of concrete and permeability, more permeability. The conclusion drawn was that the failure was because of a variety of reasons, but of course, main reason is poor quality of concrete, low concrete strength, pervious concrete, cracking and honeycombing, bad workmanship, reinforcement congestion, improper gluing of segments, improper reinforcement detailing in the blister block. The quality of coarse aggregate and fine aggregate was not up to the required specification. So because of these reasons, all the precast segments were rejected. Later, the source of aggregates was changed. Quality and workmanship standards were improved for the new segments, which were erected without any problem during the precessing operation. There are many lessons to be learned from this failure. Adequacy and acceptance of cube test results alone do not ensure good quality concrete and design strength. Apart from the strength, it's very important to ensure quality of concrete in terms of durability criteria, which are also given in our IRC codes, to ensure proper cover, reinforcement placement, and thickness of the various components. Curing is a major factor in achieving the desired concrete strength, which should be ensured. In this particular case, I think curing was also deficient. Quality control at the site should be ensured by a competent, knowledgeable quality control engineer. There should be a separate senior quality control engineer in each organization who should supervise and ensure quality control. Regular supervision should be done also by head office of the contractor, and a proper record should be maintained of all the quality control checks. And not only, it should not be sole responsibility of the contractor. The project management, supervision consultant, authority engineer, independent engineer, they should also enforce quality control diligently at all stages of construction rather than leaving it to the contractor alone. The designer should develop detailed drawing properly, especially where there is a reinforcement congestion, and increase concrete dimensions suitably to a proper space for concrete to go in. Thickness specified in design codes are minimum, and the designer should increase these at points of reinforcement and cable congestion. Self-compacting concrete or high-performance concrete should be preferred in highly reinforced sections. Overstressing of pre-stressing cables and extra elongation more than the value specified in drawing should be avoided. Pre-stress force more than the design value is detrimental to the structure. Workmanship should be improved by imparting training to the skilled manpower who work at site. And then the matter was referred to expert panel, and these are their comments, expert comments. Several similar failures have occurred in recent times, which is alarming. The main reason for such failures are poor quality of concreting, honeycombing, lack of proper curing, damaged shear key, congestion of reinforcement and precessing cable, and improper gluing and matching of segments. Quality of concrete suffers also due to heavy congestion of reinforcement and precessing cables. It's becoming a common practice to support large span with wide decks on a single superstructure comprising two webs. This causes the concentration of design forces and requires heavy reinforcement and cables, resulting in heavy congestion. Our design codes and specifications should be reviewed for the required minimum thickness of webs, deck slab, and soffit slab so as to avoid congestion. Designer too should increase the concrete dimension at location of reinforcement congestion rather than provide minimum thicknesses prescribed in the code. The codes too should address the problem and caution designers to be careful about congestion of reinforcement. Maybe there should be a separate chapter on congestion of reinforcement and how to deal with it. Shop drawing should be prepared to highlight the vulnerable locations prone to failure. High performance and self-compacting concrete should be made mandatory for such superstructure. Thank you. Thank you all.
Thank you, Ahujaji, for making this presentation. And I hope now our audience can understand how this report has been published. It has no identification marks. You cannot identify which project it is and who reported it and who are the other stakeholders in this report. And also it contains all the important technical aspects which are needed to be considered in future projects. With this, now I will request Mr. V. N. Hegde to present another similar kind of a case study, which is not related to the bridge. It is regarding some platform canopy, and that will further enforce this idea. Just listen to Mr. Hegde. That's Hegde, sir. You are muted actually. Hegde sir, you are muted. Hegde sir, you are muted.
Yeah, now can you hear me?
Yes, yes.
Yeah, thank you very much. And Mr. Ahuja has spoken about a bridge case which was reported in the Crossfall. I'm going to take a case other than the bridge, which is called the Canopy of platform, a failure of the Canopy of platform. I'm going to, sort of, demonstrate to you people as the Crossfall reporting, how it helps in really carrying forward the lessons learned by expressing discussing the failure in the form of a confidential reporting. Because such sort of a reporting is not possible for a variety of the reasons, as Mr. Bhomik said. And I have taken a case of a Canopy of platform which had failed as reported in the confidential report Crossfall. Suddenly, after the 5 months of the casting of the roof slab and standing unsupported for 3 weeks after the removal of the scaffolding. All of you are aware the canopy of the platform is a sort of a shelter shed which has been provided in the for the railway platforms basically. And in fact, this particular platform which I am talking about was conceptualized on the basis of the existing platform which was constructed almost 25 years back. And this platform was a extension of the existing railway platform. That railway platform was to be extended. So the existing platform designs and drawings were sort of supplied to the designer and said, see, to maintain the uniformity, this kind of the similar kind of the canopy of the platform has to be designed and it has to be executed. And in fact, during the investigation, as per the report, it was found during the construction of the existing platform almost 25 years back, mishap had taken place and sort of a unwritten understanding was there among the policymakers not to adopt this kind of a platforms in the future. But somehow, during the proposition of this particular platform, actually during the design, this fact was sort of omitted, or it was not sort of noticed. It had just to understand the structure of the canopy of the platform which was proposed. You can see here, it is has an inverted pyramid shaped RCC canopy. Almost this dimension may not be actually reported. Normally in the confidential reporting, we may not reflect or give the actual dimensions which has been in the reality which is there. It may be different for obvious reasons. So tentatively the diameter of the inverted roof, inverted canopy was around 18.8 meter, 18 meter. That's quite huge. And it was supported on a circular column of 750 mm dia. And also it had, it was almost around 4.5 meter tall. And within that 750 mm dia column, there was a drainage pipe which was going, as you can see in this, inside this. And the existing canopy of the platform had a cellular sort of a inverted pyramid, but it had, the proposed one had a very unusual combination of the slabs as well as the grid beams, as you can see here. And the slab was sort of very inverted, sort of a T-beam arrangement which had. And you can see the combination of the grid beams and the slab, which is connected to the slab, which is concentrically, supported on a column which has a drainage pipe of around 200 mm drainage pipe, as you can see here. And this drainage pipe, which had almost at around 375 mm from the top of the pile cap, as you can see here, was bending outwards, as you can see here. It's a drainage pipe bent at around 375 millimeter on top of the pile cap. And obviously at this location, if you look at the cross section is reduced to a large extent, and the properties is reduced to a large extent. And this vertical axis, this axis becomes a weaker plane, basically the weaker axis because of the reduction of the concrete due to the bent drainage pipe, as you can see here. And this canopy of the platform was sort of supported on the 4 600 dia board cast in situ pile, as you can given here. Just for the comparison of the existing one, which was been serving for last 25 years, and the proposed canopy of the platform, if you really look at it, in the earlier one, for the same dimension, it had a M20 grade of concrete, whereas the proposed one had M35 grade of concrete. And the grade of steel used 25 years back was 400 and Fe415. Obviously, the grade of steel which is used is Fe500 in the recent years. And percentage of the steel, maybe because the grade of steel's difference, earlier it was higher, almost around 1.3 to 0.8%, whereas 0.6% steel was there in case of the new one, as you can see here. With respect to the number of piles, for the same load cases, it will be around 4 number of 600 dia piles were used in the proposed canopy of the platform, whereas the existing one had around only 3 piles of 600 dia, and the capacity was around, as you can see here, 60 ton. We saw the 50 ton capacity of the piles for the new one. Now, the whole canopy of the platform, as I explained earlier, came down in a single body motion, and obviously, if you really look at the roof, which has come down here, not much distress is there in the roof, though it was an unusual combination of the grids of beams and slabs, unlike the earlier one, which had a cellular formation. It was a cellular formation in the structural configuration. It had fallen down. There were distresses because of the impact of the falling down. Obviously, the column had cracked. If you can see here, the mapping of the debris, if you do it here, this is the column which was there. After the removal of this canopy of the platform, a fallen platform, the debris were studied to understand the mechanism of the failure, the mode of the failure. You can see here, this is the line of the fall of the column, and the line of the fall of the column is almost around 18.5 degree to that of the north. And this is the pile cap for your information. And this was studied. So, and it was observed basically that the columns had broken in 2 locations, that is at 0.9 meter, 175 millimeter above the pile cap. This is the first, failure, and the second failure was around 900 above the pile cap, as you can see here. This measurement was done, and also it was observed that the pile cap had, in the north direction, had settled by 4 I think it may not be settled. It could be even the casting imperfections. We can say 4 is expected to have. That means obviously there was no settlement of the piles had taken place. If you really look at it, that's how it was done. Also, the reinforcement. These days also I'm observing in many cases, wherever the failures are taking place, somehow the reinforcement bonding between the concrete and the reinforcement is not that good. You can see here, that's what it looks like, though there is a slurry of concrete which is smeared on the surface of the on the reinforcement over here, but it's not like a piece of concrete which is attached. Somewhere it's a piece of concrete is attached, but it seems to have come out rather cleanly. The concrete seems to have come out rather cleanly, but there was no necking of the reinforcement. That means the reinforcement had not yielded anywhere. It looked like obviously the concrete failure, because the reinforcement obviously had not necked, and there was no reason for us to suspect the failure in the reinforcement. At the time of the collapse, the full dead load was there, and there was no live load on the roof, and earthquake was obviously not there, and the wind speed was very negligible. That was around 4 millimeters per second. But it's important to note that previous night there was a rain, and there was rain in the previous night, and it had followed the next day. And the grade of the concrete, if you really look at it, even the core testing was done on the fallen columns also, and also the earlier cube test also were results were tabulated, and compared with that, the grade of concrete was quite good. Though the design was done for M35 grade of concrete, on an average strength of the concrete was coming around by the 39 MPa to 40 MPa, as you can see here. For this condition, at the time of the collapse, when the analysis was done, Obviously, there are two sections which is critical, where the failure has taken place at around 175 millimeter above the pile cap. That is a solid section, as you can see here. And also the 375 mm at the top of the pile cap, where the section due to the bent drainage pipe is reduced to a large extent. And both the sections for that conditions of the existing at the time of the collapse, the analysis was done, and the efficiency of the sections was found to be quite adequate. If you really look at it, there was no particular problems as was the structural adequacy, the reinforcement provided. If you look at it, though for the section, obviously for the weaker section with the drain pipe, bent drainage pipe, the efficiency was going up to 0.904, as you can see here. Now, let us have a look at it. If you really analyze the failure here, failure should have occurred perpendicular to the weakest axis of the weakest plane. As you can see here, this is the weakest plane. If you really look at it, and the failure should have happened, the line of fall should have been in this direction, that is perfectly to the north direction. But the line of fall was around 18.5 degree, from that. And also the failure had not happened at 375 millimeter above the top, where the bent drainage pipeline is there. Failure had taken place at around 175 millimeter from the top of the pile cap, which is comparatively stronger section to that of the section at 375 mm at the top, the WX, as you can see here. There are two indicators here. That is the 18.5 degree, the line of fall is there, and also the failure has taken place comparatively at the stronger section. So obviously, unless there is a deviation in the geometry during construction in the north direction, in the sense if it's the outer plumb in the north direction, or the roof is cast eccentrically in the north direction, inducing large moment in that direction, a weak concrete in the north direction, and also unless there is an insufficient reinforcement. Obviously, there was at around 0.9 meter from the top of this, there was a construction joint over here. When you provide the construction joint over here, reinforcement is provided, and there's no overlapping of the reinforcement. There will be a development length of the reinforcement. If there is not sufficient development length of the reinforcement, I think that also could cause the failure at the construction joint, because the development length is not there. So unless these sort of deviations are there, the failure would not have taken place. Basically, that's what it said. So if the construction is done perfectly, according to the geometry which has been specified in the design, there is no eccentricity in the vertical columns. There is no eccentricity in the way the roof or the inverted pyramid is cast. That means 18 by 18 meter is cast concentrically. If these two conditions were perfectly followed, what could have been the reason for the failure? That is only, it is because could have happened the excessive compression in the concrete. Basically, column failed at the location which is a stronger, as I explained earlier, 175 mm above the pile cap. Sort of in the report, there were two forensic investigations done at that particular point of time, and in that report, the possibility that the concrete did not properly reach the space below the pipe. One of the conclusion was that below the drainage pipe, which is bent, there could have been a possibility the concrete may not have reached at this location 175 millimeter below. That could have caused the failure. That is one of the probability. There are so many other probable causes of the failure also. Inability to maintain the verticality of the column and inability to construct the roof concentrically. Just imagine 750 mm of column and the huge inverted pyramid of 18 by 18. It is may not be possible to construct without the casting imperfections. There is a possibility, there is a verticality, out of verticality of the column, the outer plumb of the column being, and also the roof also could have been cast not symmetrically, eccentrically. That possibility is there. And also, I told you that there was an inverted pyramid might have got filled up with the water because of the previous day's rain, which is there. That's also possible. It's a huge water accumulation. For any reason, if the drainage pipe is choked during the construction, there's a possibility of all the water being collected on the inverted pyramid. That would that clubbed with the non-verticality of the column or the eccentricity of the roof being cast not properly, eccentricity induced there. All this load can multiply the moments on the column. That possibility is there. And also at the location of the drainage pipe, the pipe is bent, and like that, it makes the sections very weak. Though the line of fall is 18.5 degree, it could have happened for variety of the reason. That could have been the section properties is reduced to a large extent, and there's a weaker section because of the bent drainage pipe over there. And of course, the underneath pipe might not have been having a good concrete integrity. That's also possible. And also, I explained to you earlier that it was standing for 5 months, and after the 5 months casting and after the removal of the centering, the structure has failed. And it could be possible that the decentering sequence may not have been properly done. And when the decentering sequence is not properly done, there could have been a small crack in the column somewhere at the weaker section. And when the rain came, the water might have got accumulated, and that could have induced the problem. So there are hypotheses of the failures could be many, as I explained to you. So what are the lessons basically learned? When you are doing a sort of a structure which doesn't have a redundancy, which is not robust, as in the case of the canopy of the platform, where the load path is only the column, a small column here, precise workmanship and the perfect construction with the geometry defined in the design is very, very important. A precise workmanship and the quality of the concrete is also very, very important. And also, I think another lesson it is learned is, as per the codes, it's not necessary to consider the full water in the inverted pyramid during the construction stage as per the code. Perhaps I think there is a possibility for whatever the reason, the drainage pipe being choked and the full inverted pyramid is fully filled up with the water. That I think also should be considered for the design of the canopy in the opinion of the report which has been there. The area of concrete at the location may be increased by the provision of the pedestal. Actually, perhaps I think in this case, this kind of pedestal, see here the bent pipeline over here is there. If this, in the case of this pipeline, where because of this, the weaker section is induced over here, to overcome this problem, to compensate for the loss of the concrete area here, there could have been a provision of the pedestal over here. That was the case in case of the earlier existing canopy. But unfortunately, in the proposed canopy, this pedestal was missing as per the report. And also the structures are sensitive to wind load suction. I think that's very, very important. For a shapes like this, like this inverted pyramid, it doesn't give a proper guidelines. The code doesn't give the proper guidelines how to consider the wind load suction. That means one side upward wind load, on the other side there is no wind. That because of that, the overturning moment which is taking place in the column, it is not very, very clear in the codes. Perhaps this has to be considered on the conservative side. I think we'll have to take a call. It's the discretionary call of the engineer. He should take that as a consider this one. And finally, I think the most important lessons learned from this is, I think the railway platforms being a public place is always crowded with the people. This type of canopy of platform, it's a totally unredundant. There is no redundancy at all in this particular canopy of platform structure. If you really look at it, there is only a column. Load path is singular, and the construction has to be very, very precise. And we cannot have a column which is not maintaining its verticality. And also the roof has to be cast 18 meter by 18 meters. Say, for example, eccentrically cast by, say, instead of 18 meter, instead of 9 meter column being placed, it could be 10 meter by 8 meter. If that sort of eccentricity is there in the casting of the roof, I think there will be the huge moment will be induced. On the theoretically, it may be possible for us to design it on the paper. I think it may not be possible for us to really execute it unless proper supervision is there, unless a lot of care is taken. So I think perhaps the structure is not that robust. It doesn't have the alternative redundant load path as a redundancy. So perhaps it may be the good idea to discontinue with this canopy of RCC canopy of platform in the opinion. So this is a lesson learned, and now we can understand that this kind of a report which has been coming in the Crossfall can help the engineering fraternity to really save our world for the posterity, and also to check the accidents which can take place. I think with this, I'll pause here, and I will hand over to the virtual podium to Mr. Mittal to take forward. Thank you.
Thank you. Thank you, Mr. Hegde, for making this very comprehensive presentation on this case study, which was published some time back in our newsletter. And now I will request Professor Mahesh Tandon to say his comments, views about the newsletter, the kind of reports we publish, and how we can we can promote this newsletter, and how and why participants should contribute in the reporting of in this newsletter, and also your views on other presentations made. Professor Tandon.
Thank you, Mr. Mittal, and greetings, friends, to this panel discussion on Crossfall. You have heard 3 excellent presentations. The first one was from Mr. Alok Bhaumik, giving you an overview of what Crossfall is all about. And the next 2 presentations by Mr. Rajiv Ahuja and Mr. V.N. Hegde were on sample reports which are published in the Crossfall. So that is what you have heard. So you know what Crossfall is all about. You also know why and how to participate in this, what I can call only a safety mission of IAS Struct-E. It is obvious that to make Crossfall a success, all IAS Struct-E members should be involved in sharing reports of failures, distress, mistakes, defects, and accidents. The area is wide. It can relate to buildings as well as infrastructure projects and any other structure in the built environment. It can cover planning, design, construction, serviceability, and end-of-life dismantling of the project itself. The lessons learned from such reports would help educate and alert the rest of the fraternity what to do and what not to do as far as safety issues in structural engineering are concerned. The reports represent a most valuable interaction that can take place amongst engineers. It has the potential of influencing codal provisions and is a potential tool to change some aspects of the way structural engineering is practiced. As you may have noticed, Crossfall is not a course that is delivered online or in physical mode. The mode of communication is by making commentaries on real life case studies. These cannot be disclosed at conferences. In all conferences, there has to be an author, there has to be a project, there has to be a declaration of where the project is located. So this is something which is not easily possible if you want to know about failures. There is always a reluctance to give out such information in the public domain. In Crossroads, such information is invariably concealed or made confidential to avoid any legal, professional, or financial implications. So you don't have to worry about when you give a report and it is published, you don't have to worry about any of these things. A confidential system allows safety issues to be reported and discussed without creating such concerns which I mentioned. These panel discussions, friends, can also be considered as an appeal to all participants to send in the reports of all the incidents which I talked about. It can be dealing with any aspect of structural engineering. And this would, of course, we will make sure that there is no mention or indication as to which project it is, who has designed or constructed it. All this will remain wrapped up in secrecy. But what comes out is that you will be able to understand why that failure took place. Or it need not be a failure, it can be a mistake, it can be a accident, but why it took place in the first place, which we are trying to avoid. And how to make sure that these things don't occur in the future. So that is really the objective of Crossfall. And I hope that people who are attending this webinar or panel discussion have at least got that in their mind, clearly understood that this is something which is most important for our profession if we have to upgrade it and make it safe for public use. Thank you.
Thank you, Professor Tandon, for giving the comprehensive summing up of the webinar in totality. So now I think we will take the question answer. So I have few questions in chat box. So Alok, I think there's some, they are not the questions. I think they are some kind of comments or remarks. Mr. Suresh Tripathi says relying on concrete cube test only can be misleading as they are subject to manipulation. Yeah, true. It can happen. Then Mr. Amrit Minhas says, hi panelists, following the design kinematics is very important. I have seen near misses where the bridge erection team tried to take certain shortcuts and almost brought the launching girder down. Alok, would you like to say something on it?
Yes, I mean, you see, because of the fast track nature of projects that we have, and because of the huge disparity or difference between the demand and supply in terms of competent professionals in the country, these series of failures are, I think, inevitable. But I think this is also an opportunity where, we need to be more cautious And these newsletter helps you to sort of, to know exactly where you have to take precautions. If you really see the statistics of the 15 case studies that we have presented, you will find commonality, and probably with more number of reports, maybe after 3-4 years, we will be also able to provide the statistics of, what are the primary causes reported. So these are the areas where we need to focus. So I think, yes, I agree with the person who has raised in Q&A box. It's a very fact that people are not taking care. Just yesterday, I was in a site of accident, and I was finding exactly the similar things.
Yeah. So next is by Mr. Suresh Tripathi. Maturity measurements in fresh concrete should be adopted, and this will give real picture of concrete strength and immediately tell the batch variation in green stage. So yeah, it's a comment. I think everybody will agree with this. Anybody would like to comment on it further? Yeah, it's true. So then Amrit Minhas says quality control engineers are looked upon as a police by execution team. Moreover, their say has not much value as these days all contractors are running after the speed of construction. Yeah. कुछ कहना चाहते हैं कोई?
Yes, if you can allow me.
Yeah.
So I know the comment is very, very valid, but I would like to correct that it is not the contractor who is only running after for fast track construction, ignoring. It is all the stakeholders involved. Somehow this culture has come in our country where the speed of construction is given all the importance, and quality takes a backseat. I mean, this applies not only to the contractor, but also to the clients and to the supervision team.
Yeah.
I think it also applies to the designers.
Yes.
I mean, the time that they get to really plan out a project properly, an important project which may cost 2,000 crores, the time that they have to plan it, to make a conception of the whole thing, it's very, very minimal. And really, there is nobody who understands in the people who are floating these inquiries that the best engineers of an organization should be really involved in the planning and concept of the design. Most of the mistakes are made there itself. And once they are a part of the system, you can make some cosmetic changes, but really speaking, the defects have already gone into the system. So I think that everybody is to be blamed, all the stakeholders, and we have to do something about it. And this crossfall is an attempt. And that is why I called it a safety mission of the IAS Struct-E. That where we can tell everybody involved that, this is something that we have to get ourselves educated and make sure that these things don't keep happening.
Yes.
May I add something to what?
Yeah. Yes.
See, if you see in present day contract, EPC contract, as Mr. Tandon said, the cost may be 2,000 crore, 3,000 crore, and these projects are becoming more and more complicated. You may have a very large cable stayed bridge. Then on both sides, you have flyovers, you have interchanges, ROBs, very complex project. And in the EPC contract has 3 components. Engineering is one of them. Now, engineering involves, the thorough investigation, boreholes, bathymetric studies, and then only designer can start unless these investigations are over. Now, the investigation alone may take 3 to 4 months, even more than that. You may have to do some 100 boreholes, maybe 50, 60 meter deep. There are not many agencies who can do it. And even if you appoint them, they will not mobilize on one day, and they may take 1 month's time in mobilizing alone. And then most of the time when these investigations are being done, there is no supervision consultant, PMC, independent, nobody is there. But contractor has to do it because his appointment date has already been fixed. And the time allocated for this activity in the contract is nil, zero. It's a zero. No time is kept aside for these kind of activities. And the first milestone is say 10%, 15% of the product. Now, how is that is not possible. So it puts a lot of pressure on designer. Contractor will pressurize designer, and in some contracts I have seen the total time for engineering design full completion is just 90 days, and you keep receiving letters from authority or owner that you have not submitted the design, and when you submit they say it has not been proof checked. Unless it is proof checked as per the contract, we will not check it. And then by the time some of designs are done, contractor is under tremendous pressure to meet the milestone. There are penalties. All the delays are attributed to the contractor. So as Mr. Alok also said, and Tandon Saab also said, it's a system failure according to me. It has to be reviewed in totality. Otherwise, and this is also one of the major causes of failure, because everybody is under pressure, including construction engineers. There's no time for review. There's no time for improvement. There's no time for making a detailed drawing. That's how this show is going on.
Yes. Okay. So I think the next question is the handling stress provisioning in precast should be mentioned in the drawing so that methodology can be designed. Okay. So I think these are just comments, and I think nobody will disagree with all those things. The designer should have planned to avoid drainage pipes. Designer would have planned to avoid drainage pipe to avoid failure. Right?
Can I-
So, yeah. Along with this, there is a during list structure, the designer may not consider the water load. He has designed the structure for wind and seismic. Hegra साहब इस पे कुछ comment बता दीजिए.
I personally believe, I think that's a relevant question, related questions later also about, how to make this canopy of, platform with the same structural configuration to make safe, the similar question has been there. I think I agree with Professor Tandon over here that many of the accidents are because of the design decisions. I always believe during the design stage, a structure can be designed in such a way it can have the higher risk of failure, and it can also have the minimum risk of the failure. It is a decision. And when it can have the higher risk of the failure, adhering to the standards and the codes which is available in the country and which is possible to design that. Take the case of this particularly canopy of platform which I explained to you, and it's a structure where the redundancy is not at all there. It's load path is single. It has to pass through the column itself, and structure is designed well. There is no problem. If you really look at it, it's adhering to all the standards and codal practices. And theoretically on the paper, if you really look at it, the structure is safe. But you see that the similar existing platform is there during this platform construction 20 years back, and as sort of a decision was made by the authorities not to go for such structures because of the mishap which took place during that construction 25 years back. That doesn't mean at that particular point of time also the structure was inadequately designed, not properly designed, even then the mishap took place. But it requires very, very high precision in the construction. Like that, we have to make sure that the verticality of the column is within the permissible limits, and also the roof is cast in such a way that there is no imperfection in the casting at all. And to do that, it may not be very easy unless there is a proper supervision, and at every stage the check is done properly. And you see, the thing is here in this particular case of the canopy of platform, is a degree of risk is higher, though the design of the structure is done in accordance with the codal as well as the standards which is available in the country at that particular point of time. It may be very difficult to adhere to the construction tolerances during the construction. Even if the construction tolerances is exceeding, I think at that particular point of time only during the supervision, we'll have to make sure that if already the non-conformity is there, taking the non-conformity in the consideration, again redesign and see whether the structure is safe or not. That's how it has to be done. That is the reason I told you that a decision was taken earlier by the authorities not to pursue with this, because their experience was it's very difficult to adhere to the construction tolerances which which can be done. I personally believe the degree of the risk of the failure can be increased during the design stage, adhering to the standards as far as the codal practices, or the degree of the failure can be minimized, taking all this, which is not given in the code also into consideration. Say, for example, the code may say that, like this during the construction, you can take only the half of the pyramid, the inverted pyramid is filled with the water. That is the construction stage design. For any reason that the drainage is choked, and if it's fully filled up with if suppose there is an eccentricity in the column itself, just imagine the magnification of moments which is coming on the column. So I think designer has to be careful and say he has to consider the eventuality of that pyramid, the inverted pyramid is fully filled up with the water. Though the code says that it can be done with the half filled water, that possibility the code says. And these are the sort of things which has to be taken into consideration. And it is the designer who has to take the call. Designer, for the economization purpose, he can just adhere to the standards and codes and make sure that the design is, like it is even we used to tell that even if the crow comes and sits on the structure, additionally the structure cannot take the load. To that effect, the design can be stretched to the limits. I think it's in the hands of the designer. That is the reason in the lessons learned of the crossfall, especially as far as the canopy is concerned, it is said that this kind of canopy may be discontinued with. It may not be a good idea to have a structure which doesn't have a robustness at all, which doesn't have a redundancy at all. That could be the one of the decision. I personally feel it is in the hands of the designer to anticipate some of the unscheduled forces which can come on the structure, though it is not mentioned in the codes and standards as far as in the contract. That's how we'll have to look at it. The structure has to be robust and it has to be redundant. And if it is a very sensitive structure and the robustness is not there, the redundancy is not there, we'll have to make sure during the supervision of the execution and the supervision, the structure is built in accordance with the permissible tolerances, within the permissible tolerances, and make sure that it adheres to all this. Like this is even the concrete. Say, for example, one of the reasons could be, as highlighted in the crosswall for the canopy of the platform, is the concrete might not have gone under the bent pipe properly. That's also possibility is there. That's one of the possibilities. So all these things have to be ensured and adhere during the supervision if you are going for a structure which is redundant, which is not robust. That's what has to be ensured, in my opinion.
Okay, thank you.
Some things what Mr. Hegde said. And
sorry.
that designer should also be trained in construction aspects. Today, the problem is there are designers who have not ventured out of their office even for years, and they are designing complex structures. So unless they are exposed to the construction, they will not learn. In all our drawing, construction sequence, erection sequence should be very clearly specified, which are normally missing. It's supposed to be construction engineer's problem, not designer's problem. So there has to be culture in sensitive structure. The construction sequence cautions should be provided, and that can be given only when designers are exposed to the construction. Otherwise, they don't know what they should give.
Okay. So I think now I will take next question. See, idea is that we need to talk about the crossfall as a newsletter. Aim is not to, I think most of the questions are technical in nature. They are in the form of comments or suggestions. So I will miss some of them. Then there is one question, Ronur Krishnappa. From last 1.5 years, I have been investigating and rehabilitated 2 major bridges and 1 aqueduct. They were in serious distress and somehow rehabilitated with great care. One more major bridge of balance cantilever balance cantilever across major river has been recommended for replacement of superstructure after due investigation. Is this, I think this is just a information. Is the canopy column ductile detailed?
No, Mr. Manoj, we can request him to contribute to crossfall.
Yeah. Yes, I think many of the people have done work, so they should contribute to the a report to the crossfall, particularly Mr. Ronur Krishnappa. Then is the segmental construction? There are no guidelines for early age thermal cracking, heat of hydration either in IRS or IRC codes. In UK and US, there are guidelines available. What is your opinion?
Yeah, I would like to take that question, Mr. Mehta.
Yes.
It's a very, very, very important question. And I've also come across during one of the forensic investigation which I did, IRC guidelines clearly gives the minimum percentage of the steel to be provided for the shrinkage as well as the temperature. It is absolutely, there is no, there is no, it is there. It's not true that there is no the percentage of the steel which has to be given for the, even IS 56 also gives for that matter, what is the minimum percentage of the steel has to be provided for both structural PCC element as well as the structural RCC element. It both gives what should be the minimum percentage of the steel which has to be provided for the early thermal cracking for various components or the various elements like slab, columns and beams, etc. It's very, very clear. Unfortunately, in IRS, the concrete bridge code, what has happened is there was a clause of the early thermal cracking, like the clause was there. What is the minimum percentage of the steel which has to be provided? But that clause has been withdrawn from the IRS CBC code 1997 in 2014 by one of the notification. It has been withdrawn because it was found that that is on a highly conservative side, and the minimum percentage of the steel which has to be provided for the early thermal cracking was coming more than the design structural steel which is in the RCC. By withdrawing that, what has happened is now there is no clause for the early thermal cracking in the IRS. That is a concrete bridge code, and that has become a problem. Like that. And the IRS also says, say for example, that all the structures have to be designed for the ultimate limit state. Once you design the structure for the ultimate limit state, and whatever the reinforcement you have to provide on the basis of the whatever the moments which is coming over there, that divided by 0.87 FY or whatever the reinforcement minimum percentage is worked out on that basis. And even if it is a structural PCC member, you will have to check under the ultimate limit state, and you will have to provide the minimum percentage of the steel. Of course, I agree. By withdrawing that clause, finding it on a highly conservative side, IRS has not done a justice over that. I think that clause, if it was found on a highly conservative side, should have been modified properly. By withdrawing that clause in the concrete bridge code on the early thermal cracking reinforcement, there is no clause in the concrete bridge code in the IRS. I think IRS code makers have to look into that basically.
Okay.
May I say something on same issue?
Yeah.
Actually, our IRC code gives minimum percentage of reinforcement. In actual practice, early age thermal cracking may lead to much higher reinforcement. We have done some work on that, especially when the sections are very thick and concrete grade is very high because of temperature difference between outside ambient temperature and inside. And some other reason, earlier thermal cracking may require much more reinforcement. In fact, recently ISFT has published a document, bridge abutments and retaining wall, and there is a chapter on earlier thermal cracking. We have taken guidance from international codes, and we find in some cases, if not all, the reinforcement requirement is much, much higher than what is specified in IRC 112. I think IRC 112 should include that chapter on earlier thermal cracking and describe various situations. So I will request listeners and participants to go through the publication by ISFT And we have solved some examples also where the reinforcement is coming out much more than the minimum reinforcement.
Yeah. Is the segmental bridge post tension with external tendons? If yes, why need wet joints? Ahuja ji, ये आपके
No, no,
Why
let Mr. Tandon or Bhaumik answer this question.
okay.
No, couldn't understand the question.
Question says, is the segmental bridge post tensioned with the external tendons? If yes, why need wet joint epoxy? Why wet epoxy joint?
No, ji,
Ah.
we have differences of opinion, I think.
No, but I think if the question is related to the presentations made by Mr. Ahuja, then I would like to mention that these are all internal bonded tendons. The project which he has shown, the details, it is not related to a project with external tendon.
Now, can I come in, Alok? I think, Mita Saab, I think if I can take that question, yes.
Okay. बताइए.
See, the question is very relevant, as Professor Tandon has said that there's a difference of opinion among the standard makers, basically as far as the external pre-stressing clubbed with the dry joints. Actually, theoretically, the external pre-stressing, why the epoxy glue is required basically to save the post-tension tendons which is there inside the concrete from the initiation of the corrosion. Basically, that's why the epoxy glue is there. Now, once the cables are outside the concrete section, I think there is no question of the epoxy glue coming into the picture. Also, the epoxy glue is never taken into consideration in the design of the design of the joints over there. So always the member is under the compression, and even the shear check, interface shear check, if it is done, that is not considered in designing. Epoxy glue is considered. But unfortunately in India, the workmanship and the quality of the construction is found to be not that good. What happens is during the construction, though the segments are match cast, either by the short line match casting method or by the long line match casting method, it has been invariably found that the match cast surfaces were not perfectly matching during the erection of that. In such situations, what happens is when the surfaces are damaged, the epoxy glue helps in like filling up the recesses which is there. Even the broken, for example, the shear keys which are there, the epoxy glue helps in like the filling up that crevices and recesses which is there. From that point of view, that the external pre-stressing, from that point of view, it is always psychologically perceived that like it's better to have an epoxy glue, irrespective whether it's the internal post-tensioning or the external post-tensioning. It's a psychological thing. It's a quality of the workmanship which is in question here. We are not able to adhere that quality of the workmanship which is required to be done for the match casting in the bridge construction.
And I think the epoxy also ensures the impermeability of the joints. If you don't put anything, the water sealing, waterproofing may be an issue. So if you put epoxy, it at least makes the joint waterproof.
Okay, so I think now we will not have more debate on these technical matters. क्योंकि हमारा वो आज का एजेंडा नहीं है actually, है ना?
No, Manoj, I just wanted to say a few words about crossfall now. If you
Alok, just तुम्हें मौका देता हूँ पहले I just finish this question answer business.
Okay.
So somebody is saying what should be the correct design for this canopy. So I think no, we will not take this. Just some questions in the question answer box. Somebody is asking, is segmental construction, there are no guidelines for early age thermal cracking, heat of hydration. वो तो हो गया ना? In use. Okay, we have covered. The canopy structures provide good area and aesthetic look, so rather discarding the same. For railway platform, in my opinion, we can prove the slab. We can prove the slab rather designing with water filled and constructed the column with composite sections to avoid buckling. Okay, so anyway, this is the subject matter of detailing, designing, and that thing. is corruption involved in type of mishaps, or is there just an act of God? ठीक है, corruption भी involved होता ही है, God, act of God भी होता है. So why bridges in Bihar collapse during construction even before inauguration? So there can be several reasons for that. Walter Allen, you okay? They ask, lifespan of a modern structure like RCC are minutes minute compared to ancestry structures that employed natural materials to a great extent. Is this a good trend? Are we for business or sustainability? इस पे आलोक कुछ कमेंट करना चाहते हो उस पे?
Yeah, I think you see what I think he's trying to say is that the old materials like masonry, bricks and all, where no reinforcement was involved, those structures are having a long service life. Many of them exist even after 2000, 3000 years. But today we are talking about concrete, reinforced concrete, where the durability is an issue. Now, you see, while it is true that sustainability concerns are there and we have to think about the longevity, but you cannot substitute reinforced concrete considering the current scenario and the availability of materials. There is no choice, let me tell you, for next 50 to 100 years to replace concrete by any other material. You can concrete can be complemented by steel and other material depending upon the situation. But by and large, majority of the construction is going to be with concrete. And the issue of sustainability now should focus on how to reduce the carbon footprint in manufacture, in placement of concrete, how to reduce the quantity of concrete in the structure, how to reduce the quantity of cement in concrete. These are the issues which we need to address rather than replacing concrete by brick and masonry.
Okay. So another question, 4 numbers in 1 month, an HEI image is damaged. We have to bend our heads in shame. Okay. Then the average life of RCC TV in superstructure is around 20 years only against the design life of 100 years. So I think we have, yeah. कुछ कहना था उदय जी, कह रहे हो?
Yeah, same issue, sustainability.
Same issue, yeah, same issue. So I think we have covered all the questions. I hope I have covered, yes. At the end, I will like to give 1 minute each of our panelists for the closing remarks, and Alok will come last. So I will start with Hegde Saab, then Rajiv Ahuja, Tandon Saab, and then Alok.
Yeah. See, the whole idea of today's panel discussion, as has been explained by the various speakers, is to bring out the causes of the failures which have been taking place, and also to learn the lessons. The idea is that is the reason that Crossfall is coming out with various failure cases without mentioning the stakeholders involved in the design as well as the construction. And it is also this newsletter is available freely, to all the people, who are interested in learning about the structural failures. And after all, what is the design? Basically, design is nothing but the anticipation of the failures and to cater to that, so that the failure doesn't take place. That is all the design is about. Basically, that's what we do in the design. We anticipate the failure, and to make sure that the failure doesn't take place, we provide the proper dimensions and the detailing so that the design, the structure doesn't fail. And we are learning lessons. I don't think such an opportunity will be available to the designers where they can learn from the failure of the others. It's not necessary they'll have to learn the failure by their mistakes. They can easily learn from the others. It is a very philanthropic sort of an idea. Basically, I think it's a noble cause, noble cause. And I think all the people who are participating in this should start reporting in this Crossfall. That's what my request to all the participants over here, so that our our environment. As somebody has said that there are 4 accidents have taken place within a month, and we all have to, bend our head in shame. I think we don't have to do that if you continue to contribute to this crossfall and learn learn the lessons from the failures. And I appeal to all those people who are participating here to give more and more confidential report to this crossfall, so that all of us can benefit, not only yourself, and all the others also can benefit, and make our society a sort of a fail-free, fail-free environment, especially in the construction. That's what my appeal is.
Yeah, thank you. Ahujaji?
Yes, I think unfortunately in our country, the failures are swept under the carpet. We may have maximum number of failures, but these are not widely reported even confidentially. See, unless we develop that, our endeavor, we will not learn. We don't learn. The moment one failure is there is a criticism, designer is criticized, contractor is criticized, but very soon, after 1 month, we have next failure. The real reason is we are not learning. So this crossfall, I think, should help. I will request all the participants to read all the volumes of crossfall and also spread a word, among their colleagues, friends, that they should also come out with their experience. And these are all confidential. And let us seriously try to learn, not only design engineers. It is equally useful for the construction engineers, because many aspects, many defects, possible defects in construction failure are also covered here. So let us, spread this word and let all the participants, and we request all the technical people from construction and design industry to contribute. I think that will help us a lot. There is no point, in hiding these things. Thank you.
Yeah, thank you, Ahujaji. Tandon Saab?
Yes. I think from whatever we have heard, just wanted to add a few things. First is that we are paying far too much attention in the design offices on analysis, because that is something which our younger engineers have become very good at. They are, super fast in making models and making 3D models and all that, and producing the analysis results. But when it comes to design, detailing particularly, there are large gaps in understanding and in actually producing drawings. They are not, I think they are pretty weak. The stronger they are in the analysis part, the weaker they seem to be in the detailing, and they are not able to understand how important that is. The second thing is about the sequence of construction, how important it is, and how important it is for the designers to specify it. That is another thing that is missing. And many of the failures that I have seen, of course, there have been failures because of lack of understanding of detailing. There have also been failures because of lack of understanding of sequence of construction, how important that is for the designer to specify. Only then his job is finished. His job is not finished by just making a drawing. Sequence of construction is an integral part of the design. So these two issues, I think I would like to highlight, and I wish that there were reports on misses or near misses on these aspects. And I think the fraternity would be greatly benefited by it. Thank you.
Yeah, sure. I think very, very important comments. Alok?
Yeah, so basically, I would like to say that, as a structural engineers, we have immensely contributed in the built environment. And in fact, society at large reposes a lot of faith in us. And that is why you know, they are staying in buildings that we build, and they travel on the bridges that, you know, we are designing and constructing. Now, but these faith that the society has on the structural engineering fraternity gets dented every time there is a failure, and where there are loss of life, loss of property, etc. So it is our responsibility as structural engineers to mitigate the risk of failures, and Crossfall is a newsletter which helps. There are many other avenues by which we can mitigate risk, but this is, as I think Tandon Saab very rightly put it, this is the safety mission of IAS Struct T. And I think it's a very easy way to contribute. I receive a lot of reports which I am not able to publish, and therefore I would like to mention very clearly that, you know, we must understand, when you as a reporter want to contribute something, what are the bare minimum things that you have to put in that report so that we are in a position to publish. Simply, you know, I have received at least 5 or 6 reports of failure from the press report. Straight away, some overhead tank collapsed and the press report is given to me for publication. That will not help. You see, if you give a report to Crossfall for publication, then you must give sufficient technical details so that, you know, the readers of the Crossfall are people who are structural engineers or civil engineers who understands the subject. So mere press release will not help. You have to give little bit more details, and those details not necessarily mean that you have to be a part of that particular structure which has failed. No. For example, you know, if you are even witnessing in your adjacent, there is a building coming up and where the quality is very bad. You may not have the dimensions of the structure, but when you are reporting, then your focus should be to sort of highlight on the issue and with your conclusions also. So it should be a technical report so that, you know, we can publish. And I certainly look forward to such reports from all of you, the participants, because the success of Crossfall will totally depend on the participation by the members and the structural engineering fraternity at large. Thank you.
Thank you, Alok. So before I conclude, there's somebody saying that very important, informative, kindly make it available on the YouTube. Yes, we can make this recording available on the YouTube. Is there any certificate? I don't think there will be any certificate for this event. How can young engineers like myself learn about the enforcement detailing? Please do arrange a webinar for this. Yes, we can arrange a webinar in future. I think these are all good suggestions. We will consider all these things. Thank you. I think with this, we can conclude this session, and we have a really very live interactive session. A lot of questions were there. And I hope now participant must have understood what is this Crossfall and why we are publishing it, why it is important for structural engineers and other stakeholders, and how they can contribute and how the report looks like. So I hope we will get more reports, and we can have more such webinar in future if required. With this, I will conclude. Thanks to all the speakers for attending this and all the audience. Thank you.
And I must thank Manoj for excellent moderation of this particular webinar. Thank you very much.
Thank you, Alok. Thank you.
Yes, thank you. Thank you, Mr. Mittal.
Thank you.
Thank you, sir. Thank you.
Thank you, everybody
Thank you.
on the panel.